Assalamu alaikum everyone. Today we are going to learn how to graph a reciprocal function by using transformations. So let's begin with an example. Some transformations are applied in order to the reciprocal function: horizontal stretch by a factor of 3, vertical stretch by a factor of 2, reflection in y-axis, translation 5 units right and 4 units up. In A part, we need to write down the equation for the final transformed function. In B part, we need to sketch the graphs of transformed function. And in the C part, we need to state the domain and range of the base and the transformed function. Right? Okay, so let's begin with the A part. So in A part, we need to write down the equation of the transformed function. Right? So first, I would like to write down the transformed reciprocal function, that is a over k into x minus d and then plus c. Right? Okay, so let me write down what is a, k, d and c. Right? Okay, so the first transformation we have given is horizontal stretch by a factor of 3. It means that my k value is 1 divides 3. Right? Then we have a vertical stretch by a factor of 2. It means that the a value is 2. Then we have a reflection in y-axis. It means the k value is negative, so it would be minus 1 by 3. Okay, then we have a translation 5 units right. It means the d value is positive 5. And we have a translation 4 units up. It means the c value is 4. Let me substitute all the values into the transformed equation. It would be f of x equals to a value is 2 over the k is negative 1 by 3 into x minus d value is 5 and then plus the c value is 4. So we have done with the a part. We wrote the equation of the final transformed function. Now moving to the b part, we need to sketch the graph of the transformed function. Okay, to sketch the graph of a transformed function, we need the coordinates. Okay, so let me write down the coordinates first. We have started the b part. Okay, now to sketch the graph, the xy coordinates changes to x over k plus d and ay plus c. Let me substitute a, k, d and c values. So means xy changes to x over k, k value is negative 1 by 3 plus d, d is 5, a is 2, y plus c is 4. Let me write down the more simplified form. So the xy changes to negative 3x plus 5 and 2y plus 4. Okay, so we have got the coordinates. Now we have to draw the table of values. Okay, we have done drawing the table. So let me write down the coordinates. So the first column we can write down x and y. So x and y, and this x and y deals with the base function, and the base function is 1 over x. That is a reciprocal function. And in the third column we are going to write down negative 3x plus 5, and in the fourth column we have 2y plus 4. Okay. Okay, so let me fix some x values. I would like to fix x equals to negative 3, negative 2, negative 1, 1, 2, and 3. And let me find out the y values. So when x is negative 3, so the y would be 1 by negative 3, so that would be minus 0.3. When x is 2, the y is negative 1 by 2, that is negative 0.5. When x is negative 1, y is 1 by minus 1, that would be equals to minus 1. When x is 1, y is 1 by 1, that is 1. When x is 2, y is 1 by 2, that is 0.5, and when x is 3, the y is 1 by 3, that is 0.3. Okay, now let me find out the values of the third column, that is negative 3x plus 5. Let me write down the values one by one, substituting the x values one by one and get the values for the third column. So when x is equals to negative 3, so negative 3 times negative 3 plus 5, so that would be equals to 9, and 9 plus 5, that is equals to 14. Right, now when x value is negative 2, so negative 3 times negative 2 and then plus 5, so that would be equals to 6 plus 5, that is equals to 11. When x is minus 1, so negative 3 times negative 1 plus 5, so that would be equals to 3 plus 5, and that is 8. When x is 1, so that is minus 3 times 1 plus 5, so that would be negative 3 plus 5, and that is equals to 2. When x value is 2, so we have negative 3 times 2 plus 5, so that is minus 6 plus 5, that would be equals to minus 1. Okay, when x value is 3, so we have negative 3 times 3 plus 5, so that is equals to minus 9 plus 5 equals to minus 4. Right? Okay, let me write down the values. It's 14, 11, 8, 2, negative 1, and negative 4. Right? Okay, let's move to the last column, the fourth one. Okay, so in the fourth column we have 2y plus 4. Let's substitute the y values one by one and get the values for the y column, the last column. So we have when y is negative 0.3, so 2 times minus 0.3 and then plus 4. So let me solve it. 2 times negative 0.3 and then plus 4, that would be equals to 3.4. Okay, when the y value is negative 0.5, so 2 times minus 0.5 and then plus 4. So we have 2 times minus 0.5 plus 4, that is equals to 3. When y is negative 1, so 2 times minus 1 and then plus 4, that is equals to minus 2 plus 4, that is equals to 2. Right? And then y is 1, so we have 2 times 1 plus 4, that is equals to 2 plus 4, that would be equals to 6. Right? When y is 0.5, so 2 times 0.5 plus 4, so we have 2 times 0.5 and then plus 4, that equals to 5. Right? And the last y value is 0.3, so 2 times 0.3 and then plus 4, so we have 2 times 0.3 and then plus 4, that would be equals to 4.6. Okay, let me fill the the last column, so that would be equals to 3.4, 3, 2, 6, 5, and 4.5. Okay, so we have done the new transformed values for x and y. Okay, so let's plot all the points onto the grid to get the graph of the transformed reciprocal function, or we can say that rational function. Okay, let's plot the points onto the graph one by one. So the first x value is 14 and the y value is 3.4. So when x is 14 over here and the y is 3.4, so 0, 1, 2, 3, and over here let's say 3.4. So 14 and 3.4, the first point we have got it over here. Right? The second point is x is 11 and the y is 3. X value is 11 over here and the y value is 3. So we have the second point, 11 and 3. X is 8 and the y is 2. X value is 8 and the y value is 2. So we have this point. X is 2 and the y is 6. X value is 2 over here and the y is 6 at the top. So we have this point. X is -1 and the y is 5. X is -1 over here and the y value is 5. So we have this point. X is -4 and y is 4.6. X is -4 over here and the y is 4, and then the 4.6 between 4 and 5. So we have the point, this point. Okay, let me connect all the points to get the graph. Okay, so we have done drawing the graph of a reciprocal function, and it has a horizontal asymptote at y equals to 4 and a vertical asymptote at x is equals to 5. Okay, to find the domain and range of the reciprocal function, or we can say that the rational function, we need the horizontal and the vertical asymptote. So we can say that the domain is x belongs to real numbers and x is not equals to the vertical asymptotes, the d value, and the range is y belongs to real numbers and y is not equals to 4. That is our horizontal asymptote. So for the domain and range of the base function, we can also find out the domain and range of the base function. So for the base function, the domain is x belongs to real numbers and x is not equals to the d value, or we can say that the vertical asymptote. And for the range, we can say y belongs to real numbers and y is not equals to the c value, or we can say that the horizontal asymptote, right? I hope you understand how to find the graph of a reciprocal function or the rational function by using transformations. If you want to watch more and get updated, then please subscribe to my channel and press the bell icon for the latest updates.